Well, good morning, team. Are you ready for some colligative properties? You've probably heard this term before in some other science class. So we're going to look at it quantitatively and qualitatively, right? So as a good chemist does, we want to look at properties of solutions where we can kind of estimate some of these, quantitatively based on when a solute, because we can look at a pure solvent, right, and study properties of that. But when we add a solute to it, how does that change things, right? So we're going to focus on four. We'll do that in the next board. We'll list out the four we're going to do. And this is just an intro to it. We'll do a separate video for every single one of these specific ones, which you've probably heard. I know for sure of one of them, probably two or three, maybe not all four. We'll find out, right? But here's some of the main points, and this is just an intro for colligative properties here, right? These are properties of solutions, right, that we can estimate, but it's based only on the number of solute particles present. So if you change the number of solute particles, you alter the property of that particular solution. And what's fascinating about this, it doesn't matter what the identity is. It's just the physical presence of these particles that somehow impact these properties of a pure solvent versus when you've dissolved some solute in it and it alters those particular properties now that you have a solution, which can be very useful if we understand how to manipulate and control that. And then we can, create more products, for people to help their lives in a better way. Rock and roll. So the equations, I want you to understand that obviously when you add a solute to a solvent, you create a solution, you're altering some of these properties. To be able to, and qualitatively, we'll look at each one separately. But quantitatively, we can only really estimate properties of ideal solutions, right? So this is really only the equations that I show you in the next four videos or so, 4 or 5 videos after this, are only gonna work for ideal solutions. So keep that underlying concept in the back of your head. This is really only going to work for ideal solutions and really, really dilute ones, right? As you start adding more and more solute particles, that can start to disrupt the quantitative analysis we're going to be applying to each of these. So let's list all four of the ones we're going to be looking at, and then call it quits for the intro. I just want you to see where we're going. Be right back. Here are the four properties, the colligative properties we're going to be looking at. And again, there's lots of properties of solutions, but these are the main four you're going to run into in your undergraduate education that deal with the number of solute particles, but not the identity of those particles. Keep that in mind. And again, ideal solutions, very, very, very dilute. So I'm going to start with, and in this particular order for a reason, start with vapor pressure lowering, and we're going to do a completely separate video for this one. So when you add solute particles to a solvent, right, because we already talked about if you have a solvent in equilibrium in a closed container with its vapor, right, so the number of liquid particles leaving equals the number of gas particles entering, you get that equilibrium. The number of gas particles, that pressure, that partial pressure there, that is the vapor pressure. Well, if I add solute particles to that solvent, it's going to lower the vapor pressure of that solvent above it. We'll talk about why qualitatively and how we can quantitatively determine or calculate that for ideal, very dilute solutions. Sweet! And we'll look at some tie lines and some really interesting thing. If I get some time, maybe look at boiling points. Which brings us to our next one. And hopefully you can see how these tie together, because when a solution, when a solvent, a liquid boils, it's when its vapor pressure equals the surrounding environmental or atmospheric or prevailing barometric pressure, right? So if you're changing the vapor pressure by adding solute particles, it wouldn't make sense that also the boiling point would change. Ooh, so maybe you can connect these before I even talk about it, qualitatively why that happens, and then we'll put some equations to this. We're going to find I have to do a video next also. It depends on this type of solute, right? Is it a non-electrolyte or an electrolyte? That changes things a little bit. So we're going to have to do a little review before we get into these. So boiling point elevation, we're going to find out when you add solute particles to a solvent, the boiling point of them combined as the solution is higher than the pure solvent itself. Oh, I wonder why. Curious chemists want to know. Well, wouldn't it make sense that if the boiling point's affected, maybe the freezing point would be affected as well? There's some pretty, phase diagrams I'll show you that you can see how it happens, but I like you to understand on a kind of a molecular level why that happens. So the freezing point of a pure solvent, like water or something like that, we know water freezes at 0 degrees Celsius. But if you add solute particles to it, that lowers it, right? So it's going to freeze below 0 degrees Celsius. I grew up in Minnesota, icing roads, things like that. So that rings a bell in my childhood, where all the cars, everybody driving cars had little rust holes on the sides, right? But above where the wheels are, because you're driving on these salted roads. The things you remember. I just remember those kinds of things. And how cold it was. That's why I'm in Southern California now. It's so warm and wonderful. And number 4, and I mentioned you probably heard of at least one. Even if you've never had chemistry, you probably heard of this concept of osmosis. We joke about it it's like, oh, I want to, study my lecture notes. I'll just go to sleep with it like this, right? And by osmosis, the information will enter my brain, right? So you have a basic concept of what osmosis is. Some of you have a very detailed biology or biochemistry definition of osmosis. But we're going to look at it from a molecular point of view, as a chemist would, and then show you how that transitions to how maybe a biologist would look at osmosis or something like that. And maybe if we have time, talk about reverse osmosis, hemodialysis, some of the cool, medical applications of it. But chemistry is about the boring fundamentals, right? Not the fun applications of it. So let's talk about, in the next video, the type of solute, electrolytes versus non-electrolytes, and how to account for that. And then we'll do a video on vapor pressure lowering, a video on boiling point elevation, a video on freezing point depression with appropriate types of problems you may run into and how to approach those, and a video on osmosis. We'll be done with colligative properties. See you for the next video.